All right, good morning to everyone. So please be reminded that we have our last quiz on next Monday. Okay, I will remind again, and most of you come later. It's the last quiz for on released on Monday, 3 p.m. Okay, so I'm not sure how far we can go in differential equation. Maybe we'll finish today. If not, we'll finish by next week. But in our last hour, we'll discuss about midterm. You'll see your midterm paper. So later, if there's any marks problem, you can let me know. But you will need to return the test paper after this section. You can take a picture. Okay, so let's recall a bit on what we did on Wednesday. So on Wednesday, we look at differential equation. Okay, possibly written in the variable of xy here, so that given any xy, you can label the tangent, right? So for example, let's say this term here, you can have some tangent like that. And then if you do it for all xy, every xy, then you will get something called the, draw first. You get something called the direction field. So maybe you can start from one of the initial problem solution. So if you start from one initial solution, then you can follow this tangent line to plot out your solution. Maybe I give you an example. So let's say the dy over dx equals to 1. Okay. We know that one of the solution is e to the x, right? Okay, so let's see in this way, how do we see it? Okay, in this way, how do we see the solution? So if you look at this dy over dx as a direction field, so here what I secretly use is actually function of two variables. Okay, this is what you haven't learned before actually. Okay, so we are secretly using this. Now the input has two numbers. Okay, output one number. And then this is what you're gonna learn in calculus 2 actually. Yeah. Input more than two numbers. Okay, so in this case here, dy over dx equal to y. There's no x on the right hand side, right? So what does it mean? So it means that the tangent only depend on y. Okay, depend on y. What does it mean? Yeah. So let's draw this direction field. Okay, so let's say here 1, 1. What's the direction field? What's the direction of the tangent here? Which is y equals to 1. So in fact, if you look at 2, 1, 3, 1, 4, 1, negative 1, negative 2, 1, negative 3, 1, right? These are all 1. It's the same. So it just depends on the y direction. Okay, does it make sense? Okay. So for example, if it is minus 1, then it will go the other. Because it's minus 1. Okay, and then if you move to 2, it will be a little bit steeper. Okay, this is the direction field. And then if you move a little even more up, then you get steeper, steeper, and steeper. And then how about you going down? You will go steeper downward. Okay. But when it close to 0, what happens? It will get less slanted until it almost reach horizontal. But it will never reach horizontal. Will it reach? Yeah, it will reach horizontal when it is y equals 0. So y equals 0, it is horizontal. Okay, no? Okay. So can you try and guess? This e to the ex, y equals to e to the x, right? What's the initial value for this to find the solution? Where do you start? Where do you start this y equals to ex? What's the initial value? Can you guess? I mean, like you evaluate y 0 has to be 1. Oh, yeah, maybe I need to write a little bit more. So y 0 evaluate to what? Huh? E to the 0 is it? E to the 0. E to the 0 is 1, right? Okay, so actually e to the x, right, is the solution that corresponds to the initial value problem of y0 equals to 1. Okay, so that you can plot out this curve here. And see or not? Okay, so this also matches up with the description that we had for e to the x, right? Last time we said e to the x has a gradient 1 at the point 0, 1. Okay, gradient 1 at 0, 1. dy over dx equals to y, but at 0, 1, the y is 1. So dy dx is 1. Yeah. Okay. So from this graph, actually, there are more solutions to satisfy dy over dx equals to y, right? For example, what? Minus e to the x also works, right? Sorry? Yeah. So minus e to the x should be something along below the x-axis. And follow this line and come down. Okay, there are more solutions to it. Maybe you can choose the solution. Y equals to negative e to the x. Correct? Is it true? So maybe you try and differentiate this. You still get minus e to the x. Because different derivative is linear, right? So you can pull the minus out, and then you differentiate e to the x, you still get e to the x. Okay, so this is also how we use the Euler method. So Euler method is you start with a point. Okay, you start with a point, and then you draw the tangent line, and then you extend a little bit, and then at this point there's a tangent line, and then you extend. There's a tangent line, extend, tangent line, extend, extend. This is how we draw this graph. We follow the tangent line at each point. Okay. But today we're going to learn a more useful way to directly solve the differential equation. Okay, not just by drawing. Okay, not just by plotting. We'll learn a more sophisticated way to find the solution. Okay, ready? Okay, so this was last time. So the technique we're going to teach you is called separable equation. Okay, separable equation. So by name, right, it says separate. Separate means what? We need to split something up. Okay, let's see what can we split up. Okay, so the question here says solve this differential equation, so dy dx in terms of y and x. Then find a particular solution that satisfies the initial condition. Okay, so after you find the solution, you should think that this solution has some constant, but we want to solve that constant. Okay, so what is this separable equation here? So let me show you. So I'll teach you by this example. All right, so once you look at this differential equation, what you do is you write all the variable on one side. You collect all the like term on one side. So for example, dy you collect with all the y's together on one side, and then dx you collect with all the x's on one side. Okay, does this make sense so far? Okay, so this is the first step. Okay, so far okay. Collect all the like variables together, same variable together. And then next, we're gonna do some magic. It is integrate on both sides. Okay, integrate on both sides. So can you do integration now? Is this the form that you familiar with? Or maybe I write like this. Now can you do integration? Both sides. Okay, first you differentiate, integrate with respect to y. Second, you integrate with respect to x. Okay, so you try integrate, see, do you get the same answer as mine? Is it correct? You increase power by 1, and then, wait, increase power by 1, divided, right? So let me see. Wait, what am I doing here? I think I'm a bit crazy. So let's try again. I think my solution is wrong in my notes. So let's compute together. So increase by 1, divide by the new power, you should get minus y divided by this 1. Okay, I think this is more plausible. Is it this? Okay, yeah. Okay, cool. So then you need to apply this initial condition to figure out what is the C. Okay, so since 2 equals to y1 equals to 2, then 2 will be equal to shoot. All right, so I think we got some problem. Okay, no problem. Okay, so then minus 1 over 2 equals to minus 1 over 1 plus C. So C is just 1 over 2, correct? Yeah. Okay. So hence, what's the solution? The particle solution is minus 1 over 1 equals to minus 1 over x plus 1 over 2. Okay. Okay, everyone got the same thing? Is it the right calculation? Check. Okay. So the magic here is we can split out dy over dx. Okay, last time I told you that d over dx is an operator, right? But it doesn't supposedly look like a fraction. Okay, so supposedly you cannot split them out. But this is a method that proven works. Okay. If you go through the definition and do the calculation, it's the same as you do it. Okay, so that's why it works. Okay, otherwise it doesn't work. Okay, so this is a technique that we use on differential equation. So if you can collect all the same variable on one side, then you can, and then you split out your dy and dx, and then you can integrate dy on one side, integrate dx on the other side. Okay. Any questions so far? Question? Okay, if no question, how about you try the next question? See what you can. Can you split up the different variable on different side and do integration? Okay, try and compute this. See what you get. Okay, so what's your answer? Anyone got answer? Felicia, you want to try? Yeah, what you get? Sorry, again. What power 2? Y. Okay, y power 2, sine y. Okay, hmm, good. Okay, so how do you do that? So you take all the y variables, go to one side with dy, and then you move all the x variable with dx on the other side. Okay, and then you do integration, okay, on both sides. So you get y squared plus sine y equals to 2x cubed plus c for some c in the. Yeah, very good. All right, so next, solve these differential equation. Okay, how about this? How do you split up? Maybe you tell me how to split up. Any idea on how to split this equation up? Huh? Just what? Minus 3i first, and then what's next? Want to try? Huh?
Multiply this side and
Divide? Multiply what? dt?
put two.
Uh, dt equals to? So you move dt over and then?
It's to one side
Mm-hmm.
and y I 15 minus 3 I
Mm.
y to the next side.
Like this? Like this.
I is a blue page and
Where? Reciprocal denominator. Okay, so you take the reciprocal. So you divide by 15 minus 3. Okay. Actually, when we do this, actually, I think we should require that r is not equals to 5. Otherwise, it doesn't work. Okay. All right. So in this case, we have separate the t variables and I variable now. Then we can do separable equation. Okay. So what we get? On one side, we should get ln. Sure. But there's a minus 3 there, right? How to integrate this? I think you should use uh what is it called? What do you call it? Integration. By substitution? Yes, good, very good. Yes, by substitution, correct. Okay. Should we do the substitution or you happy you can see this answer? Should we do the substitution? Maybe just write down what you need to substitute. So dy u equals to 15 minus 3i, and then du equals to 3 di. Okay, so that's why we have a extra minus 1 of the 3 term. Okay, right. So this form actually is not the general form that we will see. The general form we will see is this. Okay, we turn it into an exponential form. Yeah, like that. And then, yeah, yeah, is this enough? I guess we could stop somewhere around here. Move the scalar down. For some scalar in. So from here, right? Can it be even simpler? Maybe even simpler. Do you think it will be even simpler here? Exponential function is always positive here. Right? It's always positive. So meaning this absolute value here will be always uh, is true. Huh? Yes, I'm right. Because if this I is, let's say, but if this I is pretty big, right, then and this term can be negative. But I guess does it matter? Okay, it doesn't matter. Okay, so you can see that the right hand side is always positive. So really, we just only care about 15 minus 3i equals to 3t. Then you can move it around. Then you get that I should be 5 minus 3. So maybe I'm not that. This is always. See. Okay. Does it depend on my C or not? It actually depends on my A, right? Dependent on this. Should I say, okay, how about this? It depends on A actually. Let me think. Should I? Okay, maybe I add some more term here. So if A is greater or equal to 0, then it might work. Okay, otherwise maybe you can just stop here. It's good enough. Okay, any question? Any questions so far? Question? Question? Any question, Liwen? Yeah. Left side need to change. Change what? Left side E must be positive, yeah. Okay. Wait, what? Which line are you talking about? Which line? Oh, yeah. The second last line. What happened here? You right side. Uh-huh. Uh-huh. 2减3. Uh-huh. And then oh uh, okay. Depend on A, right? Uh-huh. You mean this is always positive? This one? But this A, let me think. Oh, you are right. You're right. Okay, right. Okay, so this I actually okay, so good. Okay. So this A actually come from the image of -3 to C, right? So this is always strictly greater than 0. Okay, good. So we can continue. Okay, good. Okay, good. Thank you. Alright, so this A actually is not just real number, but something in the positive group. Good. Yeah. Okay, any other question? Question? 左边啊，当前是and then 两个答案 let me think so you mean okay, well, let me think first. Let me think. So okay, so you mean okay, is that this one? You mean like this? Then can we get something like this? Right. So you will get the other answer is 30. Hmm. Hmm. Yeah. So that's what I say. I mean, like keep it like here is enough, because otherwise you write down two of them. But if you write down two of them, this is also a way to tell you how to find them. Is this what you mean? Yeah, I think just stop at here is enough. Unless unless you know that 15 minus I is always greater than 0. Yeah, let me see. Yeah, unless you know that 15 minus 3I must be greater than 0. Unless there's a condition on I guess. Otherwise, yeah, you have two solutions. Yeah. I think stop here is good enough. Yeah, any other question? Any other question? Other question? Any other question? Okay, if no, let's continue. Okay, next is about orthogonal trajectory. I'm not sure why this part get introduced, but we'll just go through one problems here. So the idea here was to find a family of curve that's intersect each curve of the family orthogonally. Okay. Did you learn orthogonal projection in linear algebra? No? Orthogonal projection. Okay, so you take a vector and then you take a subspace and then you orthogonal project it down. Then you get a orthogonal part plus the projection part. Okay, but now this is slightly special here. We will find a family of curve that's orthogonal to some other family of curve. Okay, so this is a very big job here. I think this is not a focus in this class, but just for the sake of this knowledge here. So let's say we want to find an orthogonal trajectory of the family of curve of x equals to ky squared. Okay, so x equals to ky squared actually is this parabola here. Okay, so we're gonna prove that the curve that's orthogonal to this curve, right, actually is this eclipse. Okay, this is what we're gonna show. So it's a bunch of ellipse. So it turns out that these are orthogonal. So do you still remember how to check two lines are orthogonal to each other? What will happen if two lines are orthogonal to each other? Maybe something on their gradient, or maybe on products of gradient. If two lines are orthogonal to each other, then the product of their gradient is -1. Okay, so this is how we figure out the orthogonal curve. But we're going to use a differential equation to do it. Okay, because differential equation will tell you every gradient at the point. Okay, right. So because we want to have a family of curve, right, you need a family of gradient. Okay, so this is how this differential equation comes in. Okay, so we need to find a family of gradient to figure out what are the curve they are orthogonal to. So let's find a single differential equation. Okay, that satisfied by all members in the family. So meaning you want to find gradient at every point. Okay, so at every point you want to find the gradient. So maybe I put a explanation here. Find gradient at every point on the curve. Okay. Okay. Then, so how to find it? So just by implicit differentiation, okay, what we have learned last time, so that you can get dy dx from here. So you get 1 equals to ky dy. Okay, so far, okay. So this just says that dy over dx equals to 1 over 2ky. Okay, so we want to get this dy dx in terms of x and y only. So let's substitute this k here. So this k here actually depend on xy. So we just substitute it like this. So you get y over 2x. Because this is in terms of k and y, right? Okay, we want to calculate in terms of x and y. Okay, just tell me the position, okay, or the coordinate of the point, then I will know the dy dx already. Okay, so far? So far, so good. So I find dy dx at every point on the curve already. You tell me which point, then I will tell you what's the dy dx. Okay. Second, we're gonna find the orthogonal trajectory. So basically, we need to get another gradient of the curve that we want to find, such that the product of this slope here and the slope of the tangent line must be -1. So if two lines are orthogonal, then the product of their gradient has to be -1. Okay, so this is our strategy here. So what do you think? What's the new dy dx you need? Huh? What multiply with y over 2x, you get -1. What's the new dy dx you need? So here is the gradient of orthogonal trajectory. What do you think? Hmm? What multiply with y over 2x, you get -1? Jose. What? Sorry? Do you know what we want to do here? Huh? Huh? No, answer is on the board. You know what do you want to do? Trajectory. Okay, so I'm going to get the gradient in particular. So how to get that gradient? Product with the gradient of the curve is -1. Yeah. So what do you multiply to y over 2x, you get minus minus 2x over y. Yeah. Okay, so the gradient of the orthogonal trajectory should be minus 2x over y. Okay. So then you can get the gradient at every point on your orthogonal trajectory. Then what do you do next? How do you solve for y? We will use separable equation. Separable equation. Then we'll solve dy. Y dy equals to minus 2f. Yes. Okay. And then what we get is y squared over 2 equals to minus x squared plus c. Okay, so this is a family of ellipse. Okay, so far, any problem here? Any question? Any questions so far? Okay, so this maybe this subtopic want to tell you that the differential equation is solving for a bunch of family of curves. So far, any question? Let's see what's the next part. Yeah, maybe we can stop here. Any question for this hour? Any questions so far? Okay. If no question, maybe we can break for 10 minutes. Come back at 9:56. Also, in this ratio, the problem to avoid the problem. Yeah. Ah, you mean there's an easier way to write it? Hmm. It's actually so much different. Let me see. Mm, yeah, yeah, could be one way to do it. Yeah. So you have a plus minus there. Yeah, plus minus there. Yeah. Okay,
So-
good.
So K can be in any sense.
Yeah.
Mm.
Not anything, I just this thing.
Yeah.
C is anything in a, and then K is this thing. Yeah. Okay, good. Thank you. Okay, yeah, in here or not? Yeah, in Tấn Phang, I guess not here. Wei Ye, not here. Hong Liang, yeah, I think I see Hong Liang. Xi He có Lơ Thiên, Ray Yang, Roger, Sư Man, Y Nan, Yu Tao, Yu Tao, Yi Zhe, Yi Zhe, okay. Li Wen, yeah. Ray Yang, Ray Yan, Ray Yang, Ray Yan, yeah. Zhe Han, Jia Lan, Jia Cheng, yeah. Jia Yi, Qi Jun, Wang Qijun, okay. 王一清，yeah，俊逸，相思，yeah，一林，丁真，嘉谭，嘉谭也，哦呀，陶宇，文琪，汉霞，yeah，俊逸，俊杰，sorry，新阳，新阳呢，万达，yeah，新月，玉衡，I think I see 玉衡，益田，is 益田，OK，冰城。苗冰城，苗冰城 not here yet. Okay, never mind. Auran here. Desmond, good. Tommy, Tommy here, beside you. Okay. Chong Yi, I think I didn't see Chong Yi. Ying Jie, is Ying Jie here? Papagani. Other here, not here. Jose, Ishan, yeah. Daniel, Hashim here, not here. Madia, Aaron not here yet. Brandon, I think I saw him. Alicia, Gunakanti here. Margaret, yeah. Javed in here. Gabriel, yes. Jeffrey Purity. Okay. Later, I want to see all the leaders in the next hour. If your leader's not here, maybe call him or her here. Okay. I want to talk to your leader. Call him in the next hour. Must be here. Okay, let's continue. So with this real life problem, mixing problem here. So a tank, maybe draw a tank. Okay, contain an 20 kg of salt dissolved in 5,000 liter of water. Brine that contains 0.03 kg of salt per liter water enters the can at a rate of 25 liter per minute. The solution is kept thoroughly mixed and drained from the tank at the same rate. So what does this mean here? So uh, your water containing the salt enter with a rate, and then it assumes that this 0.03 salt, right, will dissolve and mix properly with the original salt, drain out again. So it's the same rate. So you come in with 25 liter per minute. You go out also with 25 liter per minute. Okay, although the rate is the same, but then if you look at the amount of salt in terms of liter, should be different, right? Is it true? Is it true? Because uh, because after you mix in, right, your salt definitely will increase, but it depends on the volume you have. Okay, with this 5,000 liters. Okay, but anyway, let's see how it goes. So let YT be the amount of salt after 10 minutes. So what is Y0? So meaning at the time 0, what's your Y? Okay, so meaning you haven't do anything yet. You are not adding or draining stuff. So at Y0, what's your amount of salt? Can you get from this question here? Yeah, so it's just 20 kg. Okay, just 20. But then it asks you to find what's the rate of change of your salt. Okay, how do you figure out rate of change here? There is a rate of change for you, right? Given in the question, maybe two of them. One is coming in, one is going out. Okay, one is coming in, one is going out. So can you imagine what happened if your rate of change coming in is more than rate of change coming out? Then your salt will increase, right? If the rate of change of coming in is less than the rate of change coming out, then meaning your salt will decrease. Okay, amount of salt will decrease. So then dy dt here should be equals to rate in minus rate out. Okay, but then this question gave you the rate in terms of liter, but your amount is kg. Can you convert liter to kg or not? Based on the liter you have, okay, the volume you have, do you know the amount of salt? How do you know? Any relation between kg and liter? Yeah. Any relation? Did you see the density? Did you see the density? Per liter, you can figure out how many salt you have. Okay, so there's a density here actually. Per liter, how many salt you have. Okay, so you can transfer the rate regarding to volume to the rate of amount of salt, okay, to the kg. Yeah. Okay, so rate in is what? Rate in is just 0.03 kg over liter times 25 liter over meter. And then, how about rate out? So it says that it's the same rate, right? But how do you transform the How do you transform the density then? What's the density? What's the density here? What's the density here? So your rate is come in 25 liter, right? Go out 25 liter. So your volume is not changing actually. Okay, so your volume is not changing. But what could change is your volume of stock. What could change is your volume of stock. Okay. So your water that's come in and going out is the same. The amount of water coming in. So you keep it as 5,000, but the amount of salt might change. Okay, might change. So we don't know how it changed, so we leave it as one. Okay, so this is our differential equation. Okay, so far makes sense or not? Does it make sense so far? Makes sense. I think it's 200, not 2,000. Okay. Yeah. So from here, can you figure out what's the explicit solution here? You want to try and do it? Yeah. From here, see what do you get for the method we learned in the morning. Okay. So what do you get? Do you get anything? So solution you get you are by equal to 50 minus 1 you are by 100. You get negative ln of 150 minus 1. Get this? Okay. And then if you use the initial value, we actually found that c equals to minus ln 130. Okay, so in the end we get 150 minus y, absolute value equals to 130 e to the minus t over. Okay. Is it possible to simplify this? Hmm? Is it possible to simplify this? Hmm? Are we able to simplify this? So just now, Yu says, right, we could write this plus minus 120. Okay, does this make sense or not? And this will imply that y is equals to 150 plus minus 1. Let me see if this makes sense. Be let me see. Hmm. Okay. This is what you say, right, Ethan, just now. Plus minus. This is also what Lee Wen just now point out, right? But then, but then if you go to the next question, right, then this number seems quite crazy. Okay, let's try the next question. Let's try first. Let's see how it goes. Okay, next question. How much salt remain in the tank after half an hour? So meaning you take t to be 30 minutes, right? Okay, so if you compute these two solutions, these two solutions are um actually positive. So let's see if these two solutions make sense or not. Can someone click your calculator? What are these two numbers? I think one of them is 81, 838 kg. How about the other one? How about the other one? 200 something. 200. Anyone click the calculator? How about the other one? Huh? Cannot click calculator. How about the other solution? Seems like one of the solution doesn't make sense. Let's see why. How about the other solution? Anyone try and calculate the second one? What do you get? I think it is 262. Yes? Wait, calculator? No one use calculator. If you don't want to use, can use my approximation. I think it's 119.9. No, 111.9. Is it? Yeah, 111.9. So I think it's 261.9. Is it 261.9? Felicia. Still anyone try? How you know? Did you try? 161.9. Point nine, yeah. Okay, so both of these kind of make sense. Does it make sense or not? Let's see, yeah. It makes sense of this. Yeah. Makes sense of this. If it's negative, definitely we can throw it away, but both of them are positive. How do you explain this two figure? Uh, uh, that maximum. It's smaller than this, then this must be wrong. Wait, what do you mean? You mean the water that pouring out, there's more salt inside it? Yeah. Much salt. That number is less than 260. Then it shouldn't be should be wrong. Should be wrong. Everything how to make that works. So you say, are you saying that everything? So you mean there's no rate out? Wait, does it make sense that way? Does it make sense? There's no rate out. It might make sense. Uh, you sure it works like that? Okay. Wait, let's confirm that there's no mathematical error here. Let's confirm that there's no mathematical error here. Yeah, there's one step that I'm not happy with the textbook solution. How they get rid of the absolute value. There's something I need to check here. Let's see if we can try what In that case, you only live with this term, right? There's no rate out. But your rate in, is it possible? Is a deep. Let me think. Huh? Just rate in. Yeah, I know, but like how is it possible then? So this y, what happened to this one? Wait, let me think. So, 没有这一项。But then, but then, but then, but then it's a different system, right? Because there's no water going out actually. Ah, is it? Let me think. Hmm. Okay. Okay. I think it works. So let's say there's no rate out, right? So what could happen? 150. So you integrate 150. So meaning mm, you get y equals to 150 t, right? No, y is too much, right? 150 times 30. Wait. So y equals to 150. Sorry. Y equals to 0.75 t plus c, right? So let's try what you say. So let's just keep let's try. Just try only. Try if keep only rate in. Okay, just keep only rate in. Then y0 is 20, right? And then so then c equals to 20, right? Okay. And then if y 30, what happens? So at the 30-second, plus c is 20. So it's 41.5. Well, kind of makes sense. Okay, very interesting. So let's say if we keep only rate in for the salt, right? And then you do the integration. It's very simple, right? It's just a constant. So you don't even need the separable equation to help you, but then you get y equals to 0.75 t plus c. And then if you check y0 is 20, then actually that constant is 20. Then you check at 30 minutes, you will get not 21.5, right? So you multiply by 30, you get 22.5. And then you get 42.5. Okay, so we claim that this is the maximum sort you get if no salt get drained out. Kind of makes sense. 41? What do you mean? 41 or 42? You multiply by 30, right? 0.75. So let's see. Not 22.5. 0.75 times 20 times 30. 21. 22. Mm, kind of makes sense. Let's check some more. Do we have another method to see actually? Let me think. If yt is continuous. Okay, let me think. So this e to the minus t over 100 is decreasing, right? So it's decreasing, so you're getting smaller, and then okay, so let's write down the conclusion first. So things the maximum sort with no sort no sort drain up is 42.5 kg. We take 38.1 kg as our result. Hmm. Let me think if there's another way to describe this thing. Yeah. Yes. Yes. Yeah. Mm-hmm. 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 Let me see again. So you say that if you multiply 0.03 to 5,000, you get 150 kg. Huh? Normal one. Uh, hmm, true. Makes sense. Makes sense. Makes sense. True. Then how about this result here? How about this result here? Huh? Yeah, sure. I mean, like, how about this one? So this is all right, sure. Oh, so this is just at the 30 second. So maybe you are going to the maximum. I'm not sure we can reach there or not. Maybe we can't even reach that 150 as well, right? So yeah, good, very good, good point. Let me think. Good point. Let me see. Yeah, sure. Yeah. So there's another maximum you can check, suggested by. Are you our new students? Are you from other class? Okay, thank. So how do you know about our class here? Which one is your friend? Margaret at the back. Okay. Margaret told you. Okay, good. Thank you. So yeah, thank you for another friends here. So she was suggesting that because you are pouring in this salt solution, right, of 0.03 salt per liter, right? So at most you could go is just 550, but this is not sure that you can achieve or not. This is just a heuristic um, number you can get. But then, like what Yuhen said just now, right? If we just check the maximum that you will get at 30 minutes is just 42.5. Okay. So the solution that makes sense should be something less than 550 or even 42.5 because we have the exact time that given. Okay. So we pick 38. Okay. I'm not sure why the textbook can straight away throw away the other condition. I need to check again if I miss anything or not from the absolute part. Yeah. And also back from this for this equation, right? Well, if you don't like this two solution, you can write it better actually. What do I mean by that? So you basically throw your plus minus sign to the other side first. Okay, and then you do simplification here. So what do I get? So I get 15 minus plus or like that. So A over 2. So you get 5. Doesn't matter, right? Minus, plus, minus. Okay, like this. I think in this case, you can even simplify it further, right? So plus minus b like that. Okay. Let's continue. Okay, any questions so far? Any question? So I mean, like in real life, right? This is what you really need to think about. It's not just integrate both side separable equation substitute. Huh? So you need to try and make sense of what you calculated. If the calculation has no mistake, right? You need to make sense of these numbers. What are they? Okay. Right. So then let's continue a bit more before we do midterm discussion. So let's do a bit of 9.4. Maybe we will just do 1.4. If we can finish, we will finish at 1.4. Okay. So first is the exponential model. I think we met this already, okay, but we want to make it more precise here. If PT is the value of quantity at the time t, and if rate of change of p with respect to t is proportional to its size, so meaning dp over dt equals to kp. Okay, if you still remember the universe 25 I show you, right? So you may think about is the amount of rat you have or the mouses you have. Then the solution for this equation is the exponential function with the initial condition. Okay, should we prove this? I think this is quite straightforward, right? Given what we know already. Okay, so given what we have learned just now, so how we're going to solve this is we use separable uh, equation. So if we separate it, it will look something like this. Okay, and then we integrate both sides. Okay, so in this case here, we'll get ln p equals to kt plus c, then absolute p equals to e to the kt plus c. So we can turn my c into a scalar. But then now this one is easier because there's no shifting inside the absolute value. So this p has to be positive based on our assumption here, because this is a value of quantity at time t. We cannot have negative quantity. Okay, so this is more straightforward. We just let it become p equals to a times e to the kt. And then this a, like what Li Wen just now suggests, right? This is always not just real number, actually it's a positive real number because it's e to the something. Okay, so here we can make a remark here. Actually, we usually care about positive quantity. You won't get negative red, for example. There's no negative one red. And so it's positive quantity. Okay, so that's why we can get this formula here. And moreover, this A can be determined from your initial condition. So we call it P. Correct or not? Because if you evaluate this equation at time t equals 0, right? What do you left with? You left with your A. This term becomes 1. Okay? P to P applied at 0 is like, that's all is the initial condition. All right. Yeah, so this is how this formula solution come from. How about the other model? Remember we learned two model, okay? Because we have a worry that this population after reaching capacity, okay, the carrying capacity, then it won't grow anymore. Okay, that's why we introduce this 1 minus P over M. Okay, so then the solution would be M over 1 plus A times e to the kt. So how do we solve this actually? Okay, similarly, we're going to solve it using separable equation here. Is it easy to separate in this case? Basically, you just throw everything across. Okay, you just throw everything related to P across. And then you do integration. Okay. But can you recognize what kind of integral you have here? How do you solve this kind of integral? I still remember the denominator has 2 factors. So what do you mean? What do you call that? Partial fraction, right? Partial fraction. Good. So basically, you can do partial fraction here. So can we quickly do the partial fraction for you? Actually, it is 1 over P times 1 over M minus P. Okay. If you are not sure where it came from, so I throw K to the other side. If you're not sure where it came from, maybe I can write one more step for you. So we write it as M over P times M minus P. Maybe this one look better. Okay, I throw the K to the other side. Okay, so far. Okay, then in this case, this is easy, right? This is easier. Well, this is just ln P minus ln M minus P equals to KT plus C, like that. Okay, again, we need to deal with this ln stuff. So this ln is like ln of M minus P over P equals to minus KT minus C. Is that right? Because I swap the negative, because usually this term should be at the bottom, right? Because it's negative minus M minus P, but we swap it, so I put the negative sign across everywhere. Okay, so why are we doing this? So maybe we can go to the exponential now. Apply exponential such that we get e to the minus kt minus c, which is a times e to the kt, like that. And at the same time, this thing has to be positive. Why? Because, sorry, there's an extra line here. P is always positive, and then I think we assume that this P won't go over the carrying capacity. Okay, if you go over, you will have a negative growth, as we discussed last time. So this is your final solution. Can we write it better? Can we write it better? Hey, wait, can we get negative? Or actually, they assume that they can get negative in this case. Actually, in the textbook, I think they assume they can get negative. So maybe we just keep it as plus minus. They assume to be negative. But I think in the normal case, we won't care about negative. But to keep all the solution together, you just put negative. Can we solve it? Is it possible to solve this guy here? Can you solve for P? Yeah. So you just keep continuing, simplify it. P and then E M should be 1 over 1 plus A e to the minus KT, like that, right? And then you just hit your M to the other side. So we keep a plus minus stuff. or keep it. Okay, so actually in this case, this A here, right? Let me see. So this A here could have plus minus, depend on what's the initial value. Okay, I think we could, or you want to see what happened. Okay, so how about let's do it then. Assume P0 is P naught. Okay, we can find what is A. Yeah. So P naught equals to M over 1 plus minus A e to the 0, right? So you get M over 1 plus minus A, okay, and then you try and figure out what's A. Should we do this? Let's do it. So 1 plus minus A equals to M over P naught, and then A will be M over P naught minus 1, and then where should we put the plus minus? Everything. Okay. Okay, so so maybe I made a remark here. So this is from textbook, right? So actually this textbook uh already absorbed the plus minus into A. Okay. They already absorb it into A because they write A equals to plus minus E to the minus C. Okay, so this textbook, right, already absorbed this plus minus into this A. Okay, if you look at the textbook. Okay, so far any question or not? Any questions so far? Yeah, so that's why they don't have this plus minus sign because the textbook absorbed it into this term here. Okay. But then we just keep it outside. Okay, so be careful when you use this. But then maybe you might ask me what to use. What to use? Just use this. Okay, the question will set it for you to just use this formula here. Okay, so you just remember this formula is enough. They will set it in the normal sense, usual sense. But in future, right, you want to use this, be careful with this plus minus sign. Yeah. Okay. How about let's try one question? Let's try one question here. Yeah, let's try it. So please remember this form. This form is pretty important. We will use this form to calculate the solution. Instead of doing the logistics step by step, we just use doing the separable equation step by step. Because why we introduce this solution is we don't want you to go through this calculation anymore. Okay, you straight away use it. You can use it straight away. All right, so let's go to so there are two models you need to keep in the mind for your purpose for your exam or for the purpose of this chapter here is these two models you need to keep in mind. Okay, in particular, their solution. Okay, so maybe I need to stress a bit. So one model is this, our very usual model, the exponential model, the growth model here. It's just the initial, so the solution is just the initial solution multiplied by e to the kt. So this k is given in your differential equation, it's fixed, but p naught is also something that it should give you. Second is logistic model. Okay, so this is about when your population reaching the carrying capacity, uh, the growth will be decreasing. Okay, And the solution is a bit different from the growth model, the usual growth model, where the okay, can you see this is quite similar to what we had before. Okay. If you ignore this one, right, you divide it by e to the kt, it's just e to the kt. You understand? So it's just a shifting. It's just a shifting of the previous solution. Okay, but there's an m contribution. There's an m contribution. It's very similar to what we had just now, actually. If you ignore this one, right, this is just e to the kt because divide you can. It's okay. Yeah. But there's a slight translation here. I guess this translation should come from the translation of the as well. But this a is a bit special. A is m minus p, not over p. This number also makes sense actually, because m is the largest number you can reach. And p now is the starting population. Okay, so let's try this formula. But in future, you need to worry about this plus minus sign, but now no need. Okay, so just try this. Given this initial value problem here, okay, so let's try and find what's the p. I think in the end, you want to find p. But actually p, yeah, you want to find p. Well, so how to do it? Okay, so we need to write it in this kind of form first. Okay, so this is a logistic problem, right? You need to write it in the form of kp times 1 minus p over m. So you need to find, in particular, this one here is very important. You need to find this one first. Okay, so if you notice, okay, maybe I copy this logistic equation here. dp over dt is equals to kp times 1 minus p over m. Okay, good. So there's no 1 here, but can you create the 1? Do you know any way to create the 1 here? Divide by 1000, huh? So you can, meaning you factorize, okay, you factorize the 1000. So if you factorize the 1000, what do you get? dp over dt. There's so many decimal point, huh? Very annoying. So maybe I write it as 8 times 10 to the negative 7 p times 1 minus p over 1 times 10 to the 3 like that. So this is in the form of kp. So you see, kp times 1 minus p over something m like that. Okay, so in this case here, we have k equals to p, sorry, 8 times 10 to the 7, 10 to the negative 7, and m equals to 1 times 10 to the 3 like that. Then we can try and use formulas. Okay, so formulas, what do we have just now? So formula was pt equals to m over 1 plus a times e to the kt, is such that a equals to m minus p now. Okay. Okay. Right. So we have k, we have m. We should be able to find our pt now. Okay. But we still need to find a, right? But a is related to the initial value. But initial value is just 100. Okay, so you can put everything. So your carrying capacity is 1000 or 1000. But then you start with 100. Okay, you start with 100 and then you grow, and you reach 1000. Okay, so all together we have what's our a? Maybe we can compute a. A is just 1000 minus 100 over 100. You get 9. Okay, your a is 9. So your PT is M, which is 1000 from the previous checking, over 1 plus 9 times e to the minus, what's your K? K is 8 to the 10 to the negative 7. Kind of ugly, but this is your solution. Yeah. All right. So then you want to find what is P40. Maybe T is years, maybe after 40 years, or 40 hours, or 40 months. Yeah, depend on what you are checking here. Depend on what's the ecosystem you are trying to model here. Maybe tree need 1,000 years, chicken maybe need months, right? Okay, so what's 40? So 1,000 over 1 plus 9 to the e to the. So basically, this is just substitution, actually. Yeah, so you can see that if it is 40, right, what you get is just 100.0029. It's very slow, actually. Okay. Even if you go to 80, it's still slow, actually. I don't know, maybe they set the wrong number. Okay. And then, did I compute something wrong? Can you check my solution or not? Is it correct or not? Do you check your calculator? Is it correct? Is this correct? Check your calculator. What I compute, is it correct or not? Felicia, can you help check? P40, P80, are they correct? Okay, so while checking, right? So let's go to the next one. When does the population reach 900? When does it reach 900? So you just let PT equals to 900. Okay, and then try and find out what's the T that make it true. Seems like I got some number that doesn't make sense. Correct. Can anyone compute? What's this number? I think last time I computed 0.0123. Seems like doesn't make sense. P40, P80, correct? Anyone computed P40 and P80? Yeah. Which one? PT. Where? Let me see. What do you mean? Uh-huh. Uh-huh. 7 or 8? 1, 2, 3, 4, 5, 6, 7, 8. Oh, yeah, I think it's 8. Yeah, I think it's 8. Okay, thank you. So this should be 8. And then anything else I need to change? This is K, huh? K is 8. So here is 8. And then here also 8. Okay, so what do you get? So here is also 8. So here should be 8. 1, 2, 3, 4, 5. Yeah, 5. And then here got 3, 8. Yeah. What do you get? P40. Can someone compute E as well? What's E? Try and compute this value here. 1,000 over 900 minus 1 should be something less than 1. And then multiply by E to the 8 times 10 to the minus 8 over 9. Got it? Or should I let my Apple not to calculate? Try. $1,000. E to the did I get a sign right? Yeah. -8. And to the -8. Everything multiplied by 4. And calculate about. Yes, good. Solve it. Yeah, very small number. Okay. So 0 point even smaller. So +1 more 0. Okay, how about the next one? Reach 90. We ask Apple to calculate as well. 100,000 over 900. Hey, wait, nowadays, did you hear there's a laptop gets stolen in library? But you guys know who do it? Do you have any idea who did it? No. So be careful with your belonging. Please don't leave them unattended. If you leave, please bring your belonging away. Okay, can solve this or not? Wow, very good. Solve it. Very small. Very interesting, huh? Long time becomes small, but when you want to reach 900, you just need small timing. Is this plausible? Does this make sense? You think this makes sense? Do you think this makes sense? How come? When you take a longer time, it's just 100, but to reach 900, you just need a the time. It does make sense, doesn't make sense. What's the explanation to this? Let me think. When t go large, what happened to this? When t go large, e to the minus t. Let's think about e to the minus t. What's going on here? Ex is like this, right? E to the minus x should look like this. Decrease, or is it possible the population decrease? Population decrease. Yeah, the population decrease. No, wait. So you divide by this thing, huh? What do you mean by divide by this? Divide by this is just getting this picture. So I think you get this kind of picture if you divide it. Also decreasing. Actually, it's decreasing. This logistic. Oh, I see. I see. I see. I see. I see. Okay, so I mean, like, okay. Do you understand why this got the +1 here? Huh? Oh, this +1 is very interesting. Because if you just look at the e to the minus t, right, it should look something like this, right? But if you divide it by 0, then the vertical asymptote happens at x equals 0, right? So that's why they plus a 1 here, such that you can shift it to the side so that you can start somewhere at 0, t equals 0. Okay, otherwise, is it? Let me think. Let me think. 1 over x. Doesn't, not quite right. Let me think. Uh, +1 is just shift up. So 1 over e over x, what's the picture? 1 over e to the minus t. What's this picture here? Okay, let's GeoGebra do it. Or can this do or not? Let me ask him to do. E to the 1. Oh, it's just et, huh? Then that's not good then. Then, okay, never mind. I think it's just e to the x. It's increasing. How? Think we make sense of this number. Any idea? What do you think? Any idea? Seems quite weird. Any explanation? No. Let me try and figure out. Any explanation or not? Why is it longer time? The population is lower. And then shorter times, the population is large. I think I checked this with textbook that then I forget. I didn't really see what's going on. Okay, maybe if no one knows, I also don't know. Maybe let me check out first. We will update on next class. Okay. If there's no problem, maybe let me see the leader first, and then I'll give back this paper. Can all the leaders come here? I want to talk about your presentations. Yeah. Yes.
你这算法题算出来的8乘10负8是太多了。你的 k 为什么是负8的？就你这个括号里面整体每天你不应该乘回去吗？这个是负2，
好像是
哪来的负8？怎么
对。等一下，我帮你处理。OK，Okay, good, thank you. So how's your project going? How you guys project going? Have you guys start like arrange your work, and then are they doing work or not? Are your group member doing work? Yes, okay, good. So have started to like take picture, like recording or not? Haven't?
We need to record.
Yeah. You need to submit the video.
Really?
Yeah. Otherwise, how you submit video? It's not in class presentation.
Okay.
You need to record. Yeah.
We have 1 week.
You have 1 week, yeah.
Okay.
You have 1 week. How about the content? Is it okay or not? Is everyone doing okay? Yeah. How about the rest?
We'll start in the weekends.
Huh?
We will start in the weekends.
We'll start in the weekend. Okay.
We will start.
Okay. Finish in the weekend.
I don't know. I'm not sure.
How about that side? Okay. Already. Is your group member doing work? Okay. Okay. How about this side? You guys, member, okay or not? Okay. Any question for you guys or not? Know how to submit? How to save file? How to record? Any question? Not really. Not really.
Let's go.
Only submit the video. Yeah.
Not cover pages.
Declaration. I'll try and figure out. Let you know by next Wednesday. I think at most we will ask you to submit slide. That's it. Yeah, at most it's like declaration. I will try and figure out. So for the video, you either submit the link, or you can upload to YouTube, and then you give me the link. Make sure that it can be always accessed because sometimes the school need it. Just make it either public or either unlisted. Yeah. Or you put it into the SM drive also. You guys all have SM drive?
Yeah.
Yeah. The university drive.
University
Yeah, yeah, yeah. The storage drive. SM drive. You know? Don't know. How to access?
I guess box dot accent.
Yeah, 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 yeah.
It's for what?
For your all your school related stuff you can store there. It's a storage provided by the university. How many gigs you have? How many gigs? 10 gigs. Yeah, no, okay. Yeah. Okay.
So the video is the main focus is at the calculus or the theory of the
How you explain the solution stuff like that.
So we just can upload it to the Moodle directly, yes?
What do you mean?
If you want, like video, our video.
I think video is too large to upload, right?
So maybe
Just give
only
the
link.
Yeah.
And this link should be to the storage of university or
You
anything.
you can use the storage of the university or you upload to the YouTube or somewhere.
Okay.
YouTube that we can access.
Let's go midterm results.
Huh?
Midterm results. That's all.
Okay, midterm result. Okay. All right, thank you then. So I'll give you the midterm result. Each person need to be 3 minutes at least in your group. Okay, at least 3 minutes. Make sure that there are at least 3 minutes.
Maximum in this.
Sorry?
Maximum like 20 minutes.
God. Actually 3 minutes is your maximum actually, I guess.
So you can I can say in 2 minutes and that's all.
I think they want you to speak like 3 minutes. Did I? Wait, okay, let me check. Let me see. Let me see.
So overall video should be 12 minutes.
Wait. Let me check what I wrote here. I think it's at most, huh? If I'm not wrong. In the let me see. I think there's a bug here, huh? Let me check. Let me check the format. Okay, I think plus minus 30 seconds will be okay. Plus minus. Around 30 minutes, yeah. Plus minus 30 seconds is okay. Okay. 2.5 or 3.5. Yeah. And then if you are single, maybe if you're solo, maybe you need to talk a bit longer. Okay, so Wenqi. Yeah, you can come. If I call your name, you can come and think. Bingchen. Bingchen here now. No. Han Xiang. Felicia. Han Xiang, Felicia. Aaron not here. Yu Hen. Once you get your test paper, you can take picture. Okay, please take a picture because later you're gonna give back to me. Daniel. No. Gabriel. Where's Gabriel? I think I saw Gabriel right just now. Go toilet. Hashim. Okay. Chong-yi, not here. How run? Madia. Chen Fan, not here. Wanda. Jatan. Hey Jatan, why you don't write your English name? Ria. Write your English name next time. Purity. Injie. 若实，一则，一则呢？新月，别，若实，
不知道。
新月，季军，黄季军，浩云，嘉诚，相思，伟业哦，天，并杰。Please don't write anything on your test paper. It's to be confidential. 乐天，乐天，Hi, get your test paper. 新阳，新阳啊，新阳，一零，一零，Gopagani，瑞妍，Jose，Margaret，Jose then Isham，Tommy，阿德，Where's 阿德？玉涛，易清，丽文，Jeffrey。Hey, I thought Jeffrey and Gabriel was here just now. They all left already. Bingchen, sorry. Hey, Purity, where's Gabriel and Jeffrey? They're back? They go away. Toilet, don't know. Okay. Jia Yi. Jing Yi. Jing. Yeah, okay. Hey, wait. 看清楚。Gunakanti. Brandon. 嘉来。Desmond. 一田。吃慢。洪亮。OK。洪亮。一男。泽汉。Javed here. Javed. 西河。雅婷。Okay. Hey, before we start, just now Hao Yun also after finish only tell me the calculation here is wrong, because we pull the 1,000 out, is not divided by it. So actually it's deduced by until 1, 2, 3, right? 0.08. So it's -2, so -2, and then you need to change everything to -2, and then do computation again. Does the computation make more sense? Hao Yun, have you computed everything? No. Okay, then, is what? Too ugly. I mean, like, this is what you need to deal with for this kind of question. Okay, so please take a photo of your test paper, because I'm gonna collect it right after discussion. Okay, please take a photo of it. What do you mean? I thought there's a total marks inside there. There's a total mark in each session. Yeah. Okay, we will discuss the solution, see where you lose mark, or maybe if we miss some point, you can let me know later. Have you taken the picture already? Take picture of your test paper. Where is my solution? Let me find it. Here, yes. Okay, ready? You take picture, taking picture. Okay, let you finish first. Okay, so see where you lose mark, and then if we miss out some point, you can let me know after the discussion. Or do you want to know about the class result? Let me check. Maybe I can show you the class result. Okay, so the midterm we have quite high average. I think our average is around 70. And then actually we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 people above 90 actually. Yeah, 15 people above 90. But also, not very good thing is we also have around 12 people or 10 people below 55. Okay, these are very dangerous zone. Okay, so you have to do well in your final. You have to do well in your quizzes. Okay, to help pull your result up. Okay, enough. You need to do well in what?
I see. I take a picture.
You done?
Yeah.
We ever discussed yet? Okay, sure. So you also want to give feedback. Okay. Later, everyone should give feedback, but not now. So for those who are below 55, you know 55 is fair, right? Okay, so below 55, so you need to do well in your quizzes and your final, okay, to help pull out your marks. Okay, you have to put in effort inside your presentation, quizzes, your final. Okay, final will take a lot of points, so you definitely have to do good in final. Final is 40%, right? Yeah, so you have to do good in your final. And other than that, so let's check if you have more marks to get from discussion. Okay, so let's start from question 1. By the way, I think we have the highest is 99 in our class. Okay, the highest, which is 10 mark. Yeah, 10 mark the highest. All right, so let's see. Okay, so for the first question, the function is x squared over x squared minus 1, x squared minus 1 here. So first part is to find the horizontal asymptote and vertical asymptote. Second, sketch it. C, find the domain and range. Okay, find the domain and range. D, prove that this new function here is continuous at x equals to. Okay, so to find horizontal asymptote or vertical asymptote, right, what should you do? Okay, so you should evaluate some limit, right? So let's check x go to infinity, negative infinity, what's the value? Then this will be your horizontal asymptote. And then for the vertical asymptote, you just need to find a point such that it diverges. Okay, just need to find. For horizontal asymptote, right, you just need to prove one of them is enough. Where one of them. Okay. Basically, I split the mark into 5 plus 5. Okay. Horizontal asymptote, you need 5 marks. Vertical, you need 5 marks. Yes. They decided not to upload, so you will only see this in the video. Okay. Yeah. Okay. I got recording. Recording will be up. Okay. So 5 plus 5. Um, Okay, but I only receive argument now. Now you only can argue. Please don't come back and argue later because I won't touching this stuff again. So for now, if you got question, if you got any dispute, you have to settle now. Okay, so please listen carefully. If you have question, you ask now. I think a lot of people did mistake was this here. Okay, they didn't split out the plus minus. If you don't split out plus minus, the answer will be different. Okay, so you cannot just evaluate x2 minus 1. It's different answer going from right and left. Okay, this is most people doing wrong here. Other than that, I think it's fine. Other than that, it's fine. Okay, other than that, it's fine. B sketch. Yeah. So this sketch here, actually, if you follow this hint here, so you should write that. You should simplify your x squared minus x over x squared minus 1 to x times x minus 1 over x plus 1 times x minus 1. Okay, so the basic shape should be x over x plus 1. But what is this? This is minus 1 plus 1 over x plus 1. So this is what I want you to draw it out. Is it this? Or let me think. I think it's the other way. 1 minus. Yeah. Okay, so the basic shape you should at least draw is this. 1 over x plus 1. Okay, so if your shape is correct, but without this point here, maybe I'll give you 3 marks like that. Okay. I think the total mark is 4, right? Yeah, the total mark is 4. So if you're missing this point, I will deduct 1 mark. If you have this basic shape, I'll give you 3 marks. And if you have this asymptote but shape is wrong, maybe I give you about 2 like that. Yeah, so you should follow the basic shape. 1 over x plus 1. Or even 1 over x. Right. So there's a shifting on the x direction and shifting on the y direction. Okay. And then figure out what's the domain. Okay, so the domain is very obvious that there's only few points you are missing, which is this point and this point. For the rest, it is okay. Okay. And then for y, for range, the only 2 points you are missing is also these 2 points here. The horizontal asymptote and also the point that it doesn't define. Okay. And then D, I think without doing B, a lot of you already start simplifying this. Okay. I hope that you know it can be done because you are not looking at the point x equals to 1 or minus 1. Okay, but I think a lot of you already start doing this simplification at part A, and then you use this to calculate actually. Yeah. There's no issue about that because when you take limit, you don't care about the function at that particular point. Hey, hello, Aaron. We're discussing midterm now. Yeah. Okay, later you need to return to here. You can take a photo. Okay. Right. So for the last part, we want you to prove continuity. So there's really 3 things you need to do, right? You need to prove that the limit exists. Okay. The function already defined for you. Third, you need to show that these 2 are the same thing. Okay. So you need to check limit. Okay. Limit exists and then show that this equals to the value it defined there. Okay. Then you will get the full marks here. Actually, you don't need to show plus minus. You also can get full marks here because the limit exists. So you can just compute limit to x when x goes to 1. Okay, so you will get full marks there. Okay, so far any question on question 1 they want to ask? Anything you want to ask about question 1? Anything? You want to ask about question 1 or you want to see which part of the solution again? Clear? Is it clear on question 1? Or question? Any extra thing you want to check with me? Okay, clear? Okay, then we will proceed to question 2. Okay, question 2, most of them are just calculation, right? Compute limit, find k. So 2b actually is quite similar to 1b, right? Okay, but this, it will ask, instead of giving you a value at x equals 3, it asks you to find what's the value at x equals 3. And then C is to use the intermediate value theorem, but we already give you whole statement here. So the point here is to ask you whether you can apply it or not. Okay, can you find the right number to use it? And then D is to show that it's not differentiable using the differential derivative. So there's a left-right limit going on here again. Okay, so let's try. Let's see what we can do here. So let's look at A1. So you find this limit. So you realize that you can factorize it and then you cancel out. Because why? Because to find limit x going to x, we don't really care about that function at x equals to x. So we can cancel it out. And then because cos is continuous, so you can bring the limit in. And then you will get the answer. 2 is a bit tricky. Yeah? 2 is a bit tricky. So we give you the hint so that you can use the squeeze theorem. So how to use squeeze theorem here? So you should realize that the cos, right? Cos function is squeezed between 1 and minus 1. Okay, 1 and minus 1. But then what? What's the question here? But then this question here, let me see here. 1 and minus 1. And then you multiply by x squared, right? Why this question? Why this solution right like this? So weird one. I'm not sure why the solution look like this, but let me write another solution. How come this solution right this? Is it because of the cos? Oh, no way. Okay, never mind. So how about right like this? So cos 1 over x is bounded above by x squared, bounded below by minus x squared, and then limit of x to 0 of x squared is 0, and also limit of minus x squared when x to 0 also 0. Okay, so they are squeezed between two functions that converge to 0. Okay. Okay, how about the third one? Okay, so third one is I tell you what's the limit of f, what's the limit of g, and then compute the limit of this composition. Okay, because these compositions are continuous. Okay, so you can bring the limit into, for example, the square root function, and then limit is linear. Okay, you can bring into the difference, but limit also is productive. So limit of two converges product is the product of two limits. Okay, so you can split the limit up actually. Okay, this one's straightforward. Okay. B is very similar to what we had just now, right? You compute the limit to that point and then let that point equal to the value you want to get at that point. Okay, very straightforward. C, what to do here? Okay, C, what's the question of C again? Maybe we repeat the question again. So C says that we want to show that this has a solution in between 1 and 3 and another solution larger than 3. Okay. Right, so what do we do here? So let's look at this question. So we see that if you want to solve it, it amounts to this difference here equals to 0. Okay, so we want to see that whether this function here will pass through the point y equal to 0 or not. So we realize that when when this function apply at 1, or apply at 1, it goes to negative 0. When x equals to 3, it goes to, sorry, the other way around. So the other way around. So let's draw it again. So when s equals to 1, okay, then it is positive. When x equals to 3, it is negative, like that. Okay, so here is greater than 0, here is less than 0. And then it goes up again when a to 10, where a applied at 10, it goes up, so something like that. Wait, maybe go even before. Okay, let me draw again. So up, down, up, like that. Up, down, up, greater than 0. Okay, so by the intermediate value theorem, within 1 and 3, it will pass by 0. Within 3 and 10, it will pass by 0 again. Okay, there must be some point that achieve ax minus 4 cubed equals 0. Okay, so this is how you use the intermediate value theorem. So the point here is you need to figure out this 1, 3, and 3, 10, and what are their values there. Okay, because intermediate value tells you what? You can have at least a number c such that fc equals to n, and then this n here is in between fa and fb. Okay, so we had fa greater than 0, fb less than 0, then this n here is equal 0 in between. I'll try to write these. This is greater than 0, this is less than 0, and then I have an n that's in between them. Okay, the interested n is 0 because we want to solve it. So far, any question? So far? So far, okay. Okay. D is to show that sine absolute x is not differentiable. It's not differentiable. So meaning you show that the left and right limit doesn't exist. Left and they exist, but they are not equal. Sorry. Yeah. Okay. So one of the side is x, one of the side is -1. So they are not equal. I'm not marking this question. Is anyone like don't know how to do this question? I don't know how you do well in the other question because I only mark question 1. Yeah. So is anyone forgetting how to do this? Left and right limit of derivative. Are you guys doing okay or not? This part. Okay, any question that you want me to go through again, the solution? Which part you want me to go through? Yes. You get 0. Okay, later you come to me. Okay, you can keep it and then come to me later. How about the rest? How about the rest? Okay. You want me to go through any part? Okay. Yeah, let's continue first. All right. So I think 3 is most of you that can get a lot of marks, right? Okay. 3 A, B, C, I think quite straightforward. Even D also quite straightforward. Maybe E and F need a little bit of more works. Okay. So A is just differentiate linear terms. Okay, very straightforward. B is product rules. Okay. C maybe a bit harder quotient rule. D is a chain rule. So basically all the rule they test it for you. And then E is an implicit differentiation, quite straightforward. I think F you need to be careful a bit. F is what do you need? Basically you just substitute. value into your derivative. I think question 3 is straightforward. What do you think? Is it hard? Question 3? Not hard. Straightforward. Just computation. Okay. I see most of you just leave after 1 hour. Is the test paper easier? Yes. Okay, Jinjie said easy. Okay, yeah. Right. But anyway, please take your time to check your solution. Otherwise, maybe you will make some careless mistake. Okay, for this question, any question you want me to go through in detail? I think this part quite straightforward. Any question you want me to go in detail? This one? If no, then I'll go to question 4. Okay. All right, so question 4 is a bit involved, huh? So first part, we want you to use a L'Hopital rule, but we gave you a hint on maybe how L'Hopital can be used. Otherwise, this is infinity to a 0 intermediate form, right? So you want to get into the form like 0 over 0 or infinity over infinity. Fair enough. Okay. B is about finding maximum, minimum, increasing, decreasing. Okay, stationary point. Okay, very standard, like the quiz question. And C is the one that people keep asking me, what's margin? What's margin? Okay, what's margin? Okay, so the margin here refer to this picture here. So you have a poster, right? You have a paper. Right? You have paper. But your picture actually draw inside this paper, meaning you don't reach the boundary of it. So the margin is this top and bottom margin and the left and right margin. And did you guys use Microsoft Word? Do you guys use Microsoft Word? Do you know there's a margin there? You can adjust the margin. You can make your text longer, top and bottom, or left and right longer. You guys know or not? You never use, never adjust. Can I try it for you? You know, if you use Word, I think you should know what's margin, right? You see, if you look at this Word document here, did you see margin here? You cannot reach this side. You see, I type, right? You cannot go over the margin. You see? You cannot go over the margin. Top and bottom has a margin, left and right also have. Do you know you can change the margin here? Layout, there, you see, margin, there. Margin. You see? Never use, never notice. Never notice. Then you see, you can make it bigger, you see? You can make it smaller, right? Yeah. Then you can change margin. Okay. All right. Okay. Cool. So let's see how we solve these. This one is more involved. Okay, let's look at the first one, L'Hopital rule. So we want to write it in the form of infinity over infinity, right? So we just follow the hints. Okay, the hints, what the hints tells you. Use e to the ln. Okay, so basically, I guess you start from here, but I guess start from here. Then look at the bottom here. You start from here, and then you realize that e is continuous, so you can bring the limit out. So then the problem becomes finding this limit. So you need to find this limit. How to find this limit? We transform it to another L'Hopital. Then we transform it to another L'Hopital. Wait, let me see. Yeah, I think that L'Hopital make more sense, right? Because it is ln x to the 1 over x, right? So you can bring the power down. Yeah, this L'Hopital makes more sense. Okay. I think this is one of the lecture problem, right? I think we do a similar question like this. Yeah, we did something similar. Okay. Next, very straightforward. I find local maximum, minimum. So I don't sure you use first derivative or second derivative test, but I think it should be fine. But the point is you want to find stationary point first, okay, where the derivative is 0. Do you care about boundary points or not? You don't care about boundary points, right? Because this function is defined everywhere. There's no boundary here. And then you don't care about there's another point you need to care about, right? Before you find local max or local min, which is the, or what do you call it? Singular point, okay, not differentiable. But this is a polynomial, it's differentiable anyway. Okay, so you just care about stationary. Since the question asks you to find the increasing or decreasing region first, right? So actually, this is the first derivative test. It will help you to determine the local max and local min. Okay, so, well, what happened here was you have x equals 0, x equals 8 like that, right? And then the derivative is increasing, sorry, greater than 0, increasing, yeah, like that. And then decreasing like that. Okay, so that's why you have a maximum here and a minimum here. Okay, so actually this question is helping you to use the first derivative test. Okay, make sense? Yeah. Okay, any question on this part? No? Okay, let's go down. Okay, this one is the everyone asking one. Okay, so how do you fix your area then? Okay, so like what I said just now, right? Margin is the part that you're gonna throw away. So there's some part you need to throw away. So you need to determine what's your real width and real height here. Okay, so the question tells you. So it says what? It needs to make a poster that will have a total area of 252 and will have 1 cm margin on the side and 2 cm margin on the top and 1.5 margin at the bottom. Okay, so they didn't mention left side or right side, meaning both side is the same. But top and bottom is different. Okay, so there's a slight trick here. Okay, so that's why here is the 2, which is 1 plus 1. Here the 3.5 is the 2 plus 1.5. Again, top is 2, bottom is 1.5, and then left, right is the same. 1, like that. And then for the rest, I think you are okay. Is it okay for the rest? After setup, you know how to do it, right? It's exactly the same problem we did in class. But you need to start with the right setup. Oh, another word that you guys don't know is about dimension. I think we did this in class A dimension. Okay, we need to write out what's the something times something, like what's the how to say? Let me see. Dimension here is referring to the dimension of the poster. Ah, okay. So instead of talking about the area, wait, let me see. Okay, wait, let me see. Okay, sure. Okay, so this poster, right, is the paper. Okay, is the paper of 252, but this dimension is about the poster itself. So meaning this dimension is referring to the dimension of this picture here. Okay, dimension of this picture. Okay, so you need to tell me what's the width and height after taking away the margin. Okay, printed area. Yeah, I think this is the two things that people keep asking during the exam. Okay, any question? Yeah, any question? Yeah, any question you want me to go through again? Any parts you're unsure me to go through? Is it clear? Okay. You have any problem with your marks? No? Okay. What's the time now? Okay. So maybe if you don't have problem, you can give me back your test paper. If you have problem, you just stay here and then we can try to figure out. Yes，
这个值我看了一分是这个值
对啊，我看一下。好，可以放在，可以帮我放这边，放这边。放到这。
是抛了个神拉了出来的，
两分钟。
给我扣零，这个啥？
这是哪一题？
最后
最后一题，是不是他要你给这两个号码你给吗？看这两个，这两个号码你给。这两个。
那是不是可能就是我只写了一个 e 的是多少，然后我就直接这样乘过去了？所以我把 e 得出来了以后，然后我就没有把 a 具体是多少写，所以扣了我一分。
OK 吗
Yeah. You
Yes,
do
yes.
first as it does.
Yes, yes.
So the answer is correct.
Which one? Yeah. But you're not using the limit, right?
Yes.
Yeah.
So I have to use another one.
Yes, because that's how we determine the horizontal and
Okay,
vertical.
so about this.
Yeah, how about it? This one, what's the full name?
Steps.
Six.
Yes.
Okay, and then you compute the what? You use the same calculation. Let me check. Oh, wait. Why? Let me see. Why? Without going here, can you go here?
Because I just
Ah.
0, so I just
Maybe that's the reason they mislook it. I'm not sure how you go from there to here.
So
But
any chance for me?
you definitely cannot get full marks, but maybe I can give more marks, I guess. Because this is a 6 marks, right? Yeah, but maybe better next time you write this out.
All right.
Yeah. Otherwise, or at least you need to write like sign of that thing is 0, right? So that we know that you are actually. But I guess I can give you maybe 2 more. Yeah, okay.
So last question is, well, I calculate wrong, but
Okay.
on my
Step is
yes.
What do you mean copy wrong?
So in the last part, I
Mhm.
forgot to times half pi, but yes.
What do you mean?
So the correct answer is 2d times pi over 2. But I
Let me see.
forgot to times that
where is it?
pi over 2.
Question 3 here. This is pi over 2. And then, oh, you mean this one?
Yes.
No pi over 2. So you mean the last line is wrong. So what's your answer? What's your oh, they get 0.
Yes.
So you mean the step here is okay.
Yeah.
Okay. Maybe I can add another 2 marks. Maybe I can.
Okay.
Okay, thank you. I need to make changes. Yeah.
问一下，
啊，
他讲说不能用罗比特说为什么？
Why you can use Lobita？
是从这里开始。
我想一下，你在用吗？
我这边
怎么你用的长这样的？怎么跟这个长不一样的？怎么你有这样多东西出来？
试题 A
它只有这么短啊，怎么有这样多东西啊？你不是上下罗比达吧？怎么你有？你这个不是会无限做下去吗？怎么会停啊？因为如果你做错，好像另外一个方向是会一直做下去。Is it true？对吗？我有讲错了，我做错了。你罗比达是用错了啊？用错了。
应该是吧？
Yeah，所以这个 term 没有这么多诶，它不是上面是 e over x，下面是 e，这是一个 e over x。你好像 product rule 还是什么之类的。
哦，
Yeah。OK 啊 ，OK。
对啊。
Let's answer like this because the shorter.
D 2D ah.
Yeah.
Why you didn't have the definition? Why you don't have this part here? This part.
Yes.
Why you don't have this part straight away? Compute this part.
I didn't forget, but I suddenly I write this. I really forget.
What do you mean? I mean like we want to compute the left right limit, right? But why suddenly you can deduce this?
So I really forget how I can write this also.
Yeah.
But still get 0.
Because you didn't like start from the definition of derivative.
Also, do you know the answer for this one?
What's the answer for this? Yeah.
I get 0.
Why you get 0? Yeah. Why you get 0? The same solution. Why you get 0? Oh, you respect to time, or why respect to time? Just respect to D.
This?
Yeah. Respect to diameter, not time.
Oh,
Mm.
but actually,
You add a new variable into it. Yeah, it's just D, not time.
I think it.
Okay. Yeah. Okay.
I think it's
Okay. Aaron?
I only got one.
Okay.
Why is this not on the base? This one?
But no marks.
This one.
No marks. Why? Let me see. What did you do? 6, 1? 6 ah?
That's P.
Oh, sorry. No marks, right? Wait, let me see. 6B. So where's the mark? Why can't I see the marks? You mean this whole thing no marks?
Yeah, the whole thing. I don't see the marks on this.
Okay. Everything wrong? Eh? Okay, let me see. How about the rest?
I have no objections.
Huh?
The rest I have no objections because maybe that's wrong. But that is.
Wait, let me see what's going on here. Others are wrong, you mean?
There's our true. I just want to ask what this one, the first part.
Where's your part? Other parts? Eh?
I didn't have time to do this.
Wait, let me see. So, oh, is it because you didn't write this so that they cannot realize what you're doing actually? You should let it because 0 now stop
I
this.
have to say that.
Otherwise, we don't know what you're doing. Maybe I can give you a big mark now, but you definitely have to like say that I want to solve this and then this is the two
So
solution.
every time I want to
Yeah,
do the
otherwise
first derivative,
we don't
I
know
have
what you are
to
doing.
set it equal to 0. Okay. Okay.
Maybe I can give you a few marks, but yeah. Only this part.
Yeah.
What are these? Oh? Where are these not marked? Are these wrong?
Well, it's different than the solution. I think this.
Oh, okay. Oh, it's wrong. Okay. Okay. I will have a look on that. Okay.
I don't know. I don't know why this.
Why you can use Obida rule calculation? Why you can use? Let me think.
I don't know why.
Did it say?
Yeah, I'm right.
Why you can use Obida rule calculation? Why you can use?
Why I can't just.
Is it like you? I think you need to write this down. This one, this intermediate form. Right. You know,
Yeah,
class we
maybe
say.
that's right,
Yeah.
But these 3 points, I think.
I think this is standard. I think they already like everyone. If they did this, they take away 3 power. Okay, standard
Okay.
one. This one, everyone will have this. Okay. Okay.
No, okay.
Okay. Thank you.
这很大个。
Yeah. 哦，不是，这个不是这个二分之一，这个二分之一不是否，这个二分之一是二分之一。对，
像我之前做这个题的时候，那指标定义 x 不等于一就不一样。
啊，对，其实
那第二个它那边有，这里它有写 x 不等于一，那实际上 x 也不能等于负一啊。
啊，你给我想想啊。对，但是我的这个目的是说，like 想要让你知道这个 e 以外它是长怎么样的，但是在 e 以外这个点反正是不会被 define 的，是因为我们刚才写成这个形式了嘛，这个形式在这里会被 define。
毕竟的话是要写成那个就括号的形式，对吧？
啊，
就是
它要 open interval 吧，它不要 close。这个是什么题？
这第四题，
第42，你是第几个 part？第 B2，那样它要 open 嘛 open interval。
那他如果没有强调 open
可不可以 close 啊？你是说？
啊，对，
我想一下，
就是他增的时候我用中括号，然后减的时候用小，这样可以。就如果没有强调 open 的，
Ini aku udah, ini aku udah pasti.
你想想，
Ini bagus aku pasti dapat B banget.
那 open interval，等下我看一下，我们讲定义那个 increasing decreasing。
Paling kamu satu si
Aduh, tuh sih kayaknya udah.
kalau midtermnya aku masih pede tapi cuma 10% tuh udah pede kan 10%.
应该是可以啊，应该是可以，因为这个应该是可以，呀，只要确保这里面的每两个东西都
包含
不，每两个有这个两个 x 都符合这个条件的话，它的 f 就符合这个条件就可以，应该是会符合我们的情况。可以，
那我帮他看分数。
他要看分数啊，冰城啊，他叫你帮他看，
下周还会发吗？这个
不会发，然后他们自己来找我。这没有分数，对。
Enggak cuman semester ini doang masih ada semester pendek.
哎，各位们在这边啊，好圈，哦，怎么嘞？
Oh iya iya.
哎，你蛋，你还笨蛋，
Itu nambah.
Yeah.
Oh, is that totally get zero only. This number 4, the part A.
See?
Are you seeing this?
Number 4 part A 啊。
Yeah.
See Number 4 part A. Oh, okay. You want to get some marks? I mean, like, where are you using L'Hopital stuff? Did you use L'Hopital or not?
Hospital is mean that directive rights on this. I know this a little bit wrong, but
Yeah,
from
yeah.
here, this is there something wrong? That the directive.
You are doing implicit differentiation. It's okay, but it doesn't help, right, with this question. Doesn't help? Doesn't help? Doesn't help. Yeah, I mean, like, it's a living computation. Yeah.
Do you only give one mark to this? I mean, I only wrong one step.
You only wrong one step. So let's see what step you.
Yeah, yes. Actually, I admit it's not fatal wrong, but
What do you do? I don't know what you do. What do you do?
I use this. I forgot.
Oh, this is like the Injia's what Injia do. Oh, but you like, what are you doing? You are like,
That's why when I realized it in the last minute, I cannot change this. I realized it. Oh, I should usually after I only then one. I realized it.
so
in
what
the,
you want?
maybe,
So you are wrong. So what you
yeah,
want?
plus one maybe.
Why plus one? Plus where? You need to tell me plus where. Otherwise, I can just plus. Plus where? Already give one or then one or. I mean, here wrong. How to give? Where got right one? You need to tell me where is right so that I can give you correct answer.
Because I already write it in the proper function and
What
I
do you mean?
already
I mean proper function.
this one. I mean,
Yeah. This one everyone wrote this. You have to start from this one. But the point here is we want. I mean, this is from him, actually.
yeah,
Right? So like,
yeah. Okay.
I mean, it's only me that doing really a weird solution.
Yeah.
And not only, but
Maybe not only you. I don't know also. Maybe
Because
not
I
only you.
also doing like in the Google, but yeah. als-
What?
Also
Ah.
learning also from the YouTube the solution, but yeah, is it still wrong?
From YouTube?
Yeah. So yeah, still really make me confused.
Or maybe you confused. Oh,
And yeah, the exam result is really really disappointed me.
really what?
Really make me really has disappointed.
Disappointed.
Yeah.
Yeah, okay. So after this solution, can you like study again whether you can understand or not? Yeah.
Because like that's the one problem Sam that happened in algebra that like I cannot proving like how to know what the formula that I need to use.
Formal word that you need.
I mean like how to explain this the solution. That's what makes me
Did you do the textbooks as an exercise or not?
yeah. But mostly about the calculation only.
Oh, I mean, the question is mostly calculation. Which part you think is the
But yeah, seems still really difficult for me.
Did you check solution properly when you do the question?
So the final exam only about integration.
Uh-huh.
Yeah, only about integration.
Yes.
Is integration though is harder than directive. I don't know.
What do you mean?
Still no.
No hope?
Yeah,
Why no hope?
because so difficult for calculus.
you send a hot look at me. You send a hot look at me.
I mean, like first thing is you have to understand what's the lecture problem here. First, lecture question you need to understand first. And then you should do